Hey guys, you're welcome back to the reaction zone. In today's lesson, we're going to look at how to solve the question on the board on electrolysis. Now, the question is as follows. A direct current of 100 milliamperes flows for 4 hours through 3 cells in series. They contain solutions of sodium chloride, copper sulfate, and gold nitrate. Calculate the mass of each metal deposited in each cell. And we're given the atomic masses of sodium, copper, and gold. Now, since we're told to calculate the mass of each metal deposited in each cell, it means we're actually going to have 3 answers. So, and then, before we solve this question, before we begin to solve this question, there is something important that you should take a look. Whenever you're solving a question that has to do with electrolytic cells that are connected in series, it's important to note that when 2 or more electrolytic cells are connected in series, that each of these electrolytic cells receives the same quantity of electricity. So what it means is that for these 3 electrolytic cells containing sodium chloride, copper sulfate, and gold nitrate, that they will have the same values of Q. So according to this question, current is 100 milliamperes. And the unit, the standard unit for current in electrolysis is amperes. So I'm going to convert this to amperes by dividing it by 1000. And this is going to give me 0.1 amperes. Now the next thing is time. Time is given in hours, 4 hours. But the standard unit of time when solving questions involving electrolysis is in seconds. So I have to convert 4 hours to seconds. Converting 4 hours to seconds, I will first of all convert it to minutes. Remember that 60 seconds, 60 minutes make 1 hour. So converting it to minutes is going to become 4 times 60. Now, also remember that 60 seconds make 1 minute. So if I want to convert this to seconds, I have to multiply by another 60. And 4 times 60 times 60 is simply going to give me 14400 seconds. That is 14,400 seconds. Now, do not forget that Q is equal to the product of current and time. So this is simply going to become 0.1 times 14400, which is going to become 1440 coulomb. Now that I've gotten a quantity of charge, I can now proceed to find the mass of each metal deposited in each cell. Now, I can start with sodium chloride. In the electrolyte sodium chloride, the metal is sodium. So it means that the equation of the cathode is going to be sodium ion undergoing reduction to give sodium atom. Now, the charge on the ion is +1. So this means that the value of N is going to be 1. And then the atomic mass of sodium is 23. So, to get the mass of sodium that is deposited, it is simply going to be NQ over NF, where this particular N here is the atomic mass of sodium. So this is simply going to be 23 times 96,500 divided by 23 times 1440, that's Q, divided by 1 times 96,500. And the mass of sodium that is going to be deposited is simply going to be 0.34 grams. So this is the mass of sodium deposited. Now, for the second electrolyte, it is copper sulfate, CuSO4. In copper sulfate, the metal that is present is copper. So at the cathode here, the equation is going to be that copper 2 ions will undergo reduction to give copper. So since the charge on the metal ion is +2, it means that N is going to be equal to 2. And the atomic mass of copper, according to the question, is 63.5. So this means the mass of copper that is deposited is simply going to be atomic mass of copper multiplied by the quantity of charge over NF. And this is simply going to be 63.5 times 1440 divided by 2 times 96,500. And this is going to give 0.4 grams. So this means that the mass of copper that is deposited is 0.4 grams. Now going to the third electrolyte. The third electrolyte is gold nitrate. Now the metal here is gold. Now gold here exists as a trivalent positive ion, Au3+, and it's going to undergo reduction by accepting 3 electrons to give a gold metal. So the charge on gold ion is +3, so it means that the value of N is 3. The atomic mass of gold, according to this question, is 197. So the mass of gold deposited is going to be the atomic mass of gold multiplied by the quantity of charge divided by N, which is 3 times 96,500. So this is simply going to become 197 times 1440 divided by 3 times 96,500. And the mass of gold deposited is simply going to become 0.98 grams. The mass of gold deposited is going to be 0.98 grams. So I want to believe that the solution to this question is clear. Thank you very much for watching, and see you in the next lesson.